Welcome to Calculus. Whatever confidence you have will be tested. But don't worry, Stevenson has tools to help you. On this episode, Stevenson will demonstrate
I'm about to show you a pattern. Here's what I want you to do. I'm going to show you a function and its derivative. And I'm going to do it every few seconds and I'm going to reveal a new one. See if you can figure out the pattern. Have you figured out the pattern? Let me help you out. Look at the first one. Exponent 2, coefficient 1. 2 times 1 is 2. Now take the exponent, minus it down by 1. 1. Let's try another one. 3 times 1 is 3. 3 minus 1 is 2. Is this one stumping you? Well, there's a 1/3 here. 3 times 1/3 is 1. 3 minus 1 is 2. Here's another one. 5 minus 4 is 20. 4 minus 1 is 3. This has an exponent of 1. So 1 times 1 is 1. 1 minus 1 means this is 0. So x to the power of 0 is 1. The derivative of 5, that's a constant. The slope of a constant function is 0. You can think of this one right here as the derivative of x. You can think of that as the slope of x. Well, what is the slope? It's linear. It's 1. This applies also to negative exponents. Negative 2 times 1 is negative 2. However, negative 2 minus 1 is negative 3. Let's try the next one. Negative 1 times negative 4 is positive 4. Negative 1 minus 1 is negative 2. And in the last one, you have negative 3 times 2/3. So the 3 simplify and you're left with a negative 2. Negative 3 minus 1 is negative 4. What you just did is the power rule. So that is essentially the power rule given to you here. All of what I just demonstrated are these 4 rules. The power rule can be applied when you have a variable raised to an exponent. Now, this says the derivative of a constant is always 0. That should make sense because a constant function graphically is just a horizontal line. And a constant multiple rule, what that says is if you have a coefficient in front of your function, your variable, you can move it out front, do the derivative, and then just multiply it. That's illustrated here. So I could move the 5 in front, do my derivative, I'd end up with a 4. 4 times 5 is 20. And then the rule 7 just talks about how you can apply the power rule for integers. You're going to love power rule. It is super simple, it's easy, and it's one of the rules you should master. So here's another pattern. See if you can figure it out. In these problems, we're taking the derivative of polynomials. In the previous patterns I showed you, they were all monomials. So all we're doing here is notice the derivative of x squared will be 2x. The derivative of x is 1. So what this tells us is it doesn't matter how many terms. If we're adding terms or subtracting terms, you can take the derivatives of each term individually. Look at this one. 3 times 2 is 6. 3 minus 1 is 2. And the derivative of negative 4x, it's linear, is negative 4. And it doesn't matter how many terms you have. You can apply those power rules and those rules in the previous slide all at the same time, but you do it individually. This is known as the sum and difference rule. What it tells you is you can take the derivative of a sum or a difference and you can do it individually of every term and it'll give you what you need. So to find the derivative of a polynomial, just take the derivative of each monomial independently of each other. So let's do some practice problems now. Let's practice what we just learned. So the directions say find dy dx if, and then I have 2 problems here. So to apply power rule, what you're going to do, just to recap, is you're going to take whatever so let's actually rewrite this slightly. Let A be a coefficient. So I'm going to take whatever the exponent is, multiply it by the coefficient, and then reduce my exponent by 1. We're going to do that individually. So dy dx is just the derivative of the first term plus the derivative of the second term. So we're going to use those rules. So this derivative here, so dy dx equals, so this is going to be 2 times negative 1, so negative 2, and then x, and then 2, drop it down 1 level, is 1. So you don't have to write the 1 there, you can if you want. Plus, now this is the derivative of a constant. Remember, a constant's derivative is 0. So really, dy dx is negative 2x. There you have it. This is the derivative of my y function with respect to x. So this is my derivative anywhere I want my slope at. Let's try the next one. So this one may be a little confusing because how this is written, but don't be. Rewrite it like this. If you don't like how the fraction's written here, rewrite it out in front. Now let's do our derivative. dy dx is going to equal the derivative of the 1/3 x cubed minus the derivative of x. Remember, this is the sum and difference rule, so I'm using the power rule individually, and I'm using the sum and difference rule on the whole product here, or the whole quantity. So let's apply it. 3 times a third is 1. So I'm left with x, 1x, and then 3 minus 1 is 2. Now, the derivative of x, whenever you have a linear function, the derivative is the slope of it, right? But remember, linear functions have constant slopes. So I don't even have to really use calculus here. If it's asking for the derivative of x, I know the slope is 1 times negative 1, so it's minus 1. There is my dy dx. This problem says, find the x values for which the curve has a horizontal tangent. Alright, so remember, a horizontal tangent means the slope of at that curve is 0. So that means y prime, remember that's the notation for the derivative, I chose to use y prime because my function was called y, must be 0 there. So the first thing we have to do is figure out, well, what's y prime? So let's do that. Y prime is, so let's do our power rule. So 3 times 1 is 3, 3 minus 1 is 2. 2 times negative 2 is negative 4, 2 minus 1 is 1. This is linear, so its derivative is just its slope, which is 1, and the derivative of a constant is 0. So here I have my y prime. Now, I need to set it equal to 0 and solve. How did I know that? Because it's asking for x values for horizontal tangents. So you need to remember that a horizontal tangent means that the slope or the derivative is equal to 0. So the first thing I'm going to do is factor this. Now that I have it factored, if we go back to our quadratics, we're going to set this to 0. Remember zero product property, so I basically have 2 equations here, and I'm going to solve. So my answers are, there I have it. At these particular x values, this curve will have horizontal tangents.